Welcome to Hartman Math. This is lesson 6-8, the unit circle part 2, where we're going to introduce the tangent function. Before we get to that, just a little bit of a review here. Example number 1, sketch the key angle, standard position, and also give its coordinates on the unit circle. 150 degrees, so we're going to start kind of remembering where our quadrant angles are. We've got straight right 0 degrees. If we rotate a right angle 90 degrees, that puts 90 degrees at the top. Another 90 degrees takes us to 180 degrees. Then 270 degrees at the bottom. And then 360 degrees is in the same place as 0 degrees, saying that they are coterminal. One concept that you might see from time to time is that we can actually keep going. We can go another 90 degrees and say that this is also 450 degrees and so on. But 150 degrees we know is between 90 and 180. We know that it's closer to 180 than it is to 90. So we're going to go and put our initial side of the angle, and then our terminal side is going to be here in quadrant 2, and it's going to be closer to the 180. And we're going to show our arrow of rotation. And the coordinates for this one would be long going this way and short going up. And since this is 150 degrees, that means this is 30 degrees. So if we think 30, 60, 90 special right triangle, we're going to go long going left, so negative square root of 3 over 2, up, short one, 1/2. So those are our coordinates, negative 3 over the negative square root of 3 over 2, comma 1/2. It is now your turn for 225 degrees. Pause here until you got it. Initial side, terminal side, exactly halfway, and that means it's one of our 45, 45, 90 special right triangles, left and down, negative, 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 square root of 2 over 2, comma, negative square root of 2 over 2. Just a reminder, yesterday or the last lesson, we're looking at sine and cosine, sine being opposite over hypotenuse, cosine being adjacent over hypotenuse. So we already have those. Introducing now today tangent. Tangent is opposite divided by adjacent. That's kind of our focus. So the tangent of theta in the unit circle, here's our theta representing our trig triangle, standard position angle. And we know that tangent is opposite of theta divided by adjacent. And this length is y. So the opposite length is y. The adjacent length is x. So opposite is y. Adjacent is x. So in the unit circle, the tangent of theta will be the ratio of the y coordinate divided by the x coordinate, or simply put, the y coordinate over the x coordinate in terms of setting up the fraction. Example number 2, we've got a point shown on the unit circle. Got the coordinates. What is the tangent of theta? The tangent of theta is the y divided by the x. We're going to need to simplify it. This is what's known as a complex fraction. Not because it's complex or complicated, but just because it has within the numerator and or denominator, it has fractions. This one's actually a very easy one to simplify. What happens is, since the denominators are both 13, you can think of those as canceling out. So we would get negative 12 over 5, and as far as the negative, we should probably bring that out in front, because a negative divided by a positive is a negative 12 over 5. Your turn. Go ahead and pause here. Come up with the tangent of theta. All right, we would set that up as the y-coordinate, 3/5, divided by the x-coordinate, -4/5. And the 5's cancel, so we get 3 over -4. The negative should probably come out in front. Example number 3. For each angle, give its coordinates on the unit circle and evaluate sine, cosine, and tangent. So we have the paper plate unit circle. That might help. Or we can also kind of do sketches. We're thinking of theta being 30 degrees. So if we were to kind of sketch that, 30 degrees puts us here, which means we're long and then short. Long is the √3/2, short going up 1/2. So as far as coordinates go, it's going to be √3/2, 1/2. Once we've got the coordinates, we're going to use the coordinates to evaluate sine theta, cosine theta, tangent theta. Or in this case, sine 30 degrees, cosine 30 degrees, tangent 30 degrees. Same problem. Sine is the y-coordinate, so that's 1/2. Cosine is the x-coordinate, so that's square root of 3/2. Tangent is the y divided by the x. 2's are going to cancel, so it's just 1 over the square root of 3. I do not need you to rationalize the denominator. We can leave it like this. If you did rationalize it, you would multiply by the square root of 3 over the square root of 3, and you would get the square root of 3 over 3. That is an acceptable answer also. They are equivalent. I would take either one. There are certain circumstances, maybe a multiple choice, final, or something like that, where only one of these is going to be listed. Maybe it's this one, maybe it's this one. So you should be familiar with the process. All right, part B. Theta is 90 degrees. That should be pretty easy to come up with. It's straight up. So we don't really need to think about triangles. Just think about going unit circle up 1 in the coordinate plane, and we should be able to come up with our coordinates. Up 1 from the origin is 0, 1. All right, let's evaluate. Sine of theta is the y-coordinate, sine of theta. Sine of 90 degrees is 1. Cosine of 90 degrees is the x-coordinate, 0. Tangent of theta would be the y-coordinate divided by the x-coordinate. We could write 1 divided by 0. What is 1 divided by 0? Well, it's not 0. If you try it on your calculator, it's going to say error. And that is because we're not allowed to divide by 0. So when we encounter that situation, the answer is that it is undefined. It's not really a number. So we say it is undefined. And that is the true answer for the tangent of 90 degrees, or any time that we're asked to divide by 0. Right, part C, theta is 135 degrees. Let's think of what that sketch might look like. 0 degrees, we've got 90 degrees, we've got 180 degrees. So 135 is between 90 and 180, and it's exactly halfway between. It's 45 past 90. So we're looking at a 45, 45, 90, which all the legs are the same. So we're looking at going left, √2/2, up, √2/2, so the coordinates are going to be negative square root of 2, comma, positive square root of 2/2. All right, sine of 135 degrees is the y-coordinate, √2/2. Cosine is the x-coordinate. tangent is the ratio y divided by x. Now we could kind of set it up this way. We could know that it's root 2 divided by negative root 2. But really, it's a number divided by itself. And anytime you have a number divided by itself, whether it's 7 divided by 7, 20 divided by 20, you're going to get 1. But in this case, since it's a positive divided by a negative, we're going to get negative 1 as our tangent ratio for the tangent of 135 degrees. It's now your turn. Theta is now 300 degrees. Find the coordinates on the unit circle, then find the sine of 300 degrees, the cosine of 300 degrees, the tangent of 300 degrees. Pause here until you got it. All right, so 300 degrees should be quadrant 4, short going right, long going down, 1/2, negative root 3 over 2. 1/2 is the x, negative root 3 over 2 is the y. Sine of 300 degrees is the y coordinate. Cosine is the x coordinate. Tangent is the ratio. The 2's are going to cancel. Negative root 3 divided by 1. Anytime you divide by 1, you get itself. So we're talking about negative square root of 3. And that's it for today. I'll see you next time.